Here is a question on NLM. It is based on the concept of system and surrounding. You must know that one or more bodies can be considered a part of a system if they are translating with same acceleration. And when we write Newton's second law, we consider the external force. The F here is the external force, that is the force applied by the surrounding on the system. And the surrounding can apply two types of forces on the system. One is contact force, another is non-contact force. And non-contact force in most of the cases is due to the Earth's gravitational field, because unless otherwise stated, we assume that the experiment is carried out on the surface of the Earth. Also, you can read the problem statement one time. The three cylinders are arranged on a horizontal floor with their axis horizontal. So this the language of the statement clearly indicates that the G is acting like this, right? So you can get the direction of G by reading the problem statement. And now I am proceeding with the solution. So consider these three cylinders as a part of a system. If I consider these three cylinders as a part of the system, let me redraw the diagram one time. These three cylinders are my part of the system. What are the external forces? External forces are due to the agent is applying one force, it is a contact force, then the normal reaction at these 2 points, and then the gravitational force. We can take individually also, but we can also assume that it is acting above the center of mass. The total mass is 3mg and it is moving with acceleration a, because it is said that all the cylinders remain in contact. So as they are remaining in contact, they are moving with the same acceleration, since so they are a part of our system. Now we do not know the normal reaction here. Let me call it n dash and n double dash. We do not know the value of this. So we will solve the equation along x-axis. If I call this x-axis and we will write, and this is y-axis, we will write Newton's second law along x-axis. That is our first equation. Now, if I consider the normal reaction at this point is NA, here it is NB, and here it is NC. It is a push. Normal reaction is a push sort of the force, and it will act along the common normal. So the common normal is obviously the line joining the centers. And due to symmetry, you can see that this angle is 60 degree, as the three cylinders are identical in shape. Now we can draw the free body diagram of these two cylinders, the one that I am shading. If I draw the free body diagram of these two cylinders, that is, I am considering these two cylinders as a part of my system. If I solve along x-axis, what I will get? So I can get NA by 2 plus NC equal to 2F by 3. Right. And now, if I draw the free body diagram of only this lowermost cylinder, if I draw the free body diagram of only this lowermost cylinder, along x-axis I can write the equation NC plus N B cos 60 degree 1 by 2 equal to M times A, that is F by 3. And one more equation that I think I can write is look at this top cylinder. This top cylinder. So what will be the forces acting on this top cylinder? And if I balance the forces along the y-axis, balancing that, I will get mg equal to Na sine 60 degree root 3 by 2 this angle is 60 degree, so sine 60 degree root 3 by 2 plus nb root 3 by 2. So I get Na plus nb equal to 2 mg divided by root 3. 2 mg divided by root 3. Now I think I can get Na plus nb, Na minus nb from these two equations. If I subtract, then what I get? Na by 2 minus nb by 2 equal to f by 3. That implies Na minus nb equal to 2 f divided by 3. and I've also got Na plus Nb. What is that? Na plus Nb is 2 mg divided by root 3. So Na is coming equal to as f by 3 plus mg divided by root 3, and Nb is coming out as mg divided by root 3 minus f by 3. Now that I've got this, I can also get the value of Nc. So I've got all the values. Now for it to not lose contact, all these Na, Nb, Nc must be positive, because our object loses contact when the normal reaction is equal to 0. So normal reaction must not be equal to 0. For that we must have Ng by root 3 minus f by 3 must be positive. That is, f must be less than root 3 mg. That is first condition, and this thing must also be positive. It must be less than root 3 mg and greater than mg divided by root 3, and that is our required answer for this question. And one more thing was asked in the question, that is, if f is slightly increased above the range, at what point the object first loses contact. So say f is made above, increased beyond root 3 mg. When f is increased beyond root 3 mg, notice that Nb will become negative. That is, there will be a point where Nb will become 0, and afterwards it will become negative. So if this achieves the value 0 first, if Nb achieves the value 0 first, so the at the point B the contact will be lost first. That is, at this point, let me mark it again. At this point the contact will be lost first, and so the answer will be, it will be lost first at point B.